Hello again. This video I'll be doing VLSM, variable length subnet masking. And what you should have done prior to watching this is to look at the fixed length subnet masking, understand your binary to decimal conversion, and understand the AND function. So there are videos for that and samples and everything. I've still got the same spreadsheet that I had before, and this is where we finished up with the fixed length subnet mask, so it's an extension of that. If you don't remember it, the fixed length one, we started with the 192.168.10.0 network, and I added 2 bits to the subnet mask from a straight C class address and subnetted that C class address. So the subnet mask became .192 in the last octet, and we created 4 equal sized networks: the 0 network, 64 network, the 128 network, and the 192 network. And we worked out all the ranges from them based on, that's the network number, that's the broadcast address. So the first available IP is add 1 to the network number, and the last available IP in the range of hosts is to subtract 1 from the broadcast. Okay, so variable length subnet masking is not quite how the name suggests it is. It doesn't vary. You can't adjust it on the fly, as some people have imagined. What we do is actually subnet the subnet. And that's all it is. So once you've created a subnet, and when you first create your networks, you create a set of subnets, all with a fixed length, like we have here. And then you go, I want to make my network smaller again. So you grab one of these subnets, one of these 4, and you make it smaller. So let's imagine that we've got a network up here that requires 62 different hosts, and let's imagine that we now want 2 networks that have 30 hosts in each, or thereabouts. Yeah, maybe 29 or something like that. Well, if we've got one network that has 62 hosts required, then we leave that first network number alone. That has 62 hosts. There it is. But what we can do is grab this subnet and subnet it. So subnet the subnet. So let's do that. Let's give ourselves a little bit of space here. So I'm still not used to this package, so we'll just insert rows below. Well, that's not what I wanted, was it? I wanted these ones. Let's undo that. Sorry. I said it, and as I was talking, it messed me up. So let me just insert rows below here, and we'll do that again. Okay. So these 2 networks down here still exist. They still have 62 hosts in each, so that's fine. So I'm just going to focus on the orange network up here. And the network we're starting with, I'll just clean up a little bit, is this one. So this is not a C-class address. It's been subnetted. The network portion is that long, and that number in binary is our network number. And if I were to write that right down here, 192.168.10 dot, there's 1 bit in the 64, so that's 64 is my network number. Actually, I've got it in the wrong spot down there, but that doesn't matter. Okay, so that's the network that we're actually starting with. Let me put the subnet mask in. So it's all 1s, all the way back there. Yeah, got it. Good. Let's center it all. And these are zeros on the right hand side here. So that is the network number with the subnet mask. So what I'll do is just highlight that in a slightly different color. It's my subnet mask. It was a sort of orange, wasn't it? Make a slightly lighter orange. That'll do, that'll do. Okay, just for those orange stuff. So that is what we're starting with. That's our network number, all zeros in our host portion, and that's our broadcast, all zeros out there, and that's where it finishes, in binary. So what I've said is that I want to end up with two networks which ends up with 30 hosts in each. So if I start with this network number, how many bits do I need to borrow to end up with two networks? Well, it's 2 to the power of 1, so I need to add 1 bit into my subnet mask there. So like we did before, I'll make that yellow to say this is now our subnetted bit. We've added 1 extra bit into our subnet mask, so let's just make that green just to differentiate. That's what we originally started with, everything back there. And now we've added 1 bit into my subnet mask, and we now need to work out how many networks we've ended up with and what their values are. So if you remember from last time, we always have a 0, 1. Even if it's only 1 bit, it's a 0, 1 to start with. So 0, 1 there, 0, 1 there. So our two new network numbers are going to be 0, and let me leave a bit of space, and 1. All the prefix is going to stay the same. So the 192.168.10.64 is going to stay the same. And if you go back and look at my previous video on fixed length subnet masking, you'll see that that's exactly the case. I've said that before. What we're doing is just subnetting in binary. It doesn't matter whether it's classful or not. It's just in the binary. And how many bits we extend, we just follow the rules. We then need to convert it very carefully back to decimal so we can configure our devices. Okay, so there we have it. There's my subnet bit, and there's my subnet bit there. So let's differentiate this whole space just a little bit, just to make it slightly clearer. So we'll pop that value in there. Now this is just the last octet that I'm playing with. This is our original values, so I'll make that a slightly different color as well. Let's move it up a little bit. And now we've subnetted, so this is my new network numbers. So we'll move that up a little bit more. And then this last portion is our host portion. So what was originally our host portion is now smaller. So let's kill that. So our host portion now is that bit. Our network portion now is that lot. Just for this network. That network hasn't changed. That is still 192.168.10.0 network. We have subnetted the 192.168.10.64 network up here. Done. We've actually done everything we need, more or less. Let's just go and work out a few things. What is our subnet mask? What are our new network numbers? And what is the range of available hosts in them? And the range of available, or how many network IPs, available in each one. Okay, so there's my last octet. The network number is going to be all zeros in the host portion. The same for this new network number here. It's going to be all zeros in the host portion. So let's have a look at what this network number is. 192.168.10. That still hasn't changed, and it's got 1 in the 64, so 64. I don't know if you remember in the last video, that first subnet will always have the same network number as the parent network that we've subnetted. In our case, we'd subnetted the 192.168.10.64. There's the value up there. And now we've got an extra bit in the subnet mask, so it'll have 27 bits instead of 26. That's the difference between the two. Okay, what's this network number down here? So 192.168.10.64 plus 32 is 96. That's our new network number. All zeros in the host portion. Now the broadcast address is going to be all ones in the host portion for that network. So what is that value? That is going to be 64 plus 31. Again, it's going to be one less than the next network number. So, value there, 192.168.10.95. How do we work out the first IP address for this? We add 1 to the host. So, it's a bit rude, isn't it? I was expecting it to do all zeros, so let's add the 1 there. So that's correct. So we've added 1 from the rightmost bit into that value there. So now our value is 64 plus 1, 65. So the IP address, the first available IP address, 192.168.10.65. The last available IP address is going to be 1 less than that value. And I'll just type it in this time because my copying and pasting is terrible. So there it is there. So it is 64 plus 16 plus 8 plus 4 plus 2. So that will be 1 less than the broadcast address. So that value there, 192.168.10.94. Let's have a look at this network down here and redo what we've just done. So that is my network number now. And let me pop it down there. And we'll add in our broadcast, and we have previously added in our network number. So what are those values? So that value there is 96. This value here is actually still 1 less than the next network number beyond. So it is 192.168.10.127. Now this can only work for a thing called contiguous networks. Contiguous networks means they sit side by side in this range here, and at the moment all these networks are contiguous, even though 2 of them have a different length subnet mask. These 2 networks here have 27 bits in the subnet mask. That network up there, that one, and that one all have 26 bits in the subnet mask. So we're manipulating and playing with it. But contiguous is they're neighborly, sitting side by side. Okay, so let's keep going with this. So there's our network number there, and pop it in. Now this all stays the same. Sorry, I haven't kind of looked back on that. That 192.168.10 always stays the same, so I'm not manipulating it. I'm just manipulating the small portion here in my last octet. Now the first value is going to be the same as the previous one, really, in binary, because our network numbers are different. And the last value is going to be the same as the previous one in binary, because the network number is different as well. And you can check that if you like. So that is correct. So that value there, 192.168.10.95, 10.97 is my first IP address. The next value below is going to be our last IP address in this range, and it will be 126 in the last octet. So 192.168.10.126 is the last available IP address. Now, how many hosts have we got in each of these? It runs from 65 up to 94. And that is actually 30 hosts in that range and 30 hosts in that range. So we've actually lost a couple of addresses because of those two. The 95 and the 96 have been lost because they are now network numbers and broadcasts for different networks, so they've been lost out of the total number of IPs that we are using from our original ones. But that's fine. We've got better control over our network. So what we've done is actually variably length subnet mask. If we want to put it in a bit clearer, this network number up here has a /26 CIDR, CIDR notation. It says there's 26 bits in the subnet mask. This network here has 27. This network here has 27. This network here has 26. And this network here has 26. So there it is. We've actually done it. We have done variable length subnet masks by subnetting the subnet. We will do it slightly differently a bit later. I'll do another video on this, but this is just taking the idea that I want to create an extra one network or an extra two networks or whatever it is, and just taking it from a parent. What we'll do in the next video is actually look at the number of hosts that we want in the network, which is a better way of actually designing it. But the fundamental idea behind this is that we originally started with a C class address before we did fixed length subnet masking. We then subnetted that to give ourselves 4 equal sized networks, and then we grabbed one of those networks and then subnetted that to give ourselves again 2 equal sized networks, but they're sub-networks. So we subnetted the subnet, which is what we want. And that's it. And the same rules apply. Network number will always have zeros in the host portion. It'll have all ones for the broadcast, and then the range of available addresses inside it is to add 1 to the host portion and subtract 1 from the broadcast. And if you follow those rules, chances are you're going to get things pretty close and correct most of the time. All good. That's that video done. We'll see you in the next one. Cheers.